Alright, in my ever-loving quest to try to present you guys with stuff that will teach you, I also need to present you guys with some entertaining crap as well to entertain the masses, because that's what people watch videos for, is not just to learn, but for just pure entertainment, because that's what people do. Okay, so today, not many people use any of these anymore. These things were a godsend a while ago. They were great little units. This is the digital loggers. Which model is this one? PoE Injector. It's a Midspan PoE Injector. So basically what you've got here is it doesn't have any switching capability at all. None at all. It is strictly a power supply. These are all 10100 ports. They are all passive PoE, so compatible with most MikroTik, Ubiquiti, Telrad, Trango, all that wonderful crap. Yeah, so each one of these ports, basically, all it does is you've got, what is it? Your blue and your browns. So, what is that? 1, 2, 3. So 4, 5, 7, and 8 are charged. So you would plug your PoE devices into the lower ports, and you would plug your data into the upper ports here. This thing has a web management interface, which I will show you guys after the teardown and overview segment. And yeah, let's get down to the heart of her. So first things first, let us plug her in. And I'm going to plug her in a special way so that I'm going to actually use the batteries on this first. Because a lot of people are looking at using all DC plants, which is a good idea. I kind of like it myself. It's not a bad idea. Let's see here. So we'll come in here. We will put you 4 amps. And I will plug my positive in here. Let's reorganize a little bit. There we go. So now I've got a power supply here to show you how much current it's drawing while it's running. Okay, let's plug her in now. Boop. Alright, so she's booting up. This is an old girl, by the way. Oh, hold on. Let's just fix our flow on the amp meter here, so you can watch how much current it draws. Okay, so firmware version 1.6.7. Yeah. I reset this thing back to factory defaults for obvious reasons. I also taped off the piezo's so that it wasn't as loud. So this guy currently is running off your DC ports. It's got a 24 volt. It kind of runs as a UPS, I guess you could say. You could run it on strict DC if you take this jumper out, which would allow you to just connect it into a DC plant and use an external PSU or off-grid charging system. Or you can actually just hook up a set of 24 volt batteries to 12 volts SLAs to use as a UPS. This thing gives you absolutely no monitoring over your battery voltage or state, so it's not the wisest choice for a UPS because you don't know what your battery states are or if you're even off-grid. Okay, so yeah, we'll look at how much voltage this thing puts out in its charging current after we do a little bit of a take apart. Okay, so once again, this is a 10100 Midspan PoE. Here's your LAN interface because, again, it's not switched, so you have a separate management interface. If you go through this little guy, you can use the up and down arrows to choose your different ports, and then you can turn your port on or turn your port off. Easy as that, or cycle it, which is what I did. So, on, off, and listen, you can hear the relays. Or power cycle. Come on, cycle it. Yeah, whatever. Okay, so first things first. So let's plug in something here. I want to show you guys some interesting characteristics of this little bad boy. I have cables everywhere. Where are my cables? Oh, here's one. Okay, so I specifically made this one just for the purposes of testing stuff around here. So this is for testing the PoE output of a passive 24 volt PoE, or just your standard. So we don't want that set for amps. We want that set for DC volts. We're going to go 200, and I'm going to plug it into port 8 here. And let's turn on port 8. So I'm going to go climb here. There we go, port 8. So now here's the interesting part: is up here on this power supply, up there. That power supply is set for 25.8 volts, so I don't entirely know how accurate this thing is. Now, if I go up to a float voltage, which would be, let's see here, 14.2, so that'd be 28.4. So we're actually at a full charge battery voltage right now, and you'll see it's 24.1. Now, if I climb a bit, as you can see, it's locked at 24.1, okay? So I'm at 29, 30 volts right there. This guy is taking it, by the way. We'll go to 31 volts because that is your equalized voltage. I'm afraid to do so. There we go. I'm at 31 volts input on this guy, which is your equalized voltage on a solar charging system. And as you can see, it's stuck at 24.1. Now here's what bothers me. If I drop the voltage, watch this. I am going down, going down. Once I get below, so that's right there, that is about 13 volts on your per cell. So that's 26 volts. And as you can see, it's starting to dip. So once you get below the 28 volt mark, it kind of follows the lead of the battery bank, which is an issue because, as you all know, as you decrease the voltage, the current draw will increase to compensate, so the power output is a constant. So right now, if this was any proper 24 volt system, it would have turned itself off to prevent overcurrent damage and whatnot. Like right there, 18 volts would technically be about 9 volts per cell. That's not a healthy voltage for a 24 volt battery bank or a 12 volt cell. Your cutoff voltage on this should actually be around 20. I would say a good safe one would be 21 because that would be 10.5 per battery on a dual 12 volt cell. So it should cut off at that point, but it doesn't. It just keeps going down with the battery bank. That is troubling. Now, if you listen closely, you'll hear the relays cut out once it gets really low. It has to get down to 9 volts before the low voltage cutout kicks in and disconnects the the radios from this thing. That's terrifying. At that point, your batteries are screwed, and you're going to have some damage. And if I look at my bench meter here, it's actually, once it gets under 12 volts, that's when it actually does the cutoff. So it's almost like this thing was programmed for a 12 volt battery bank. But, I mean, clearly it's designed for 24 volts. It's really bizarre. Now I'm going to climb the voltage again here. So climbing, climbing, climbing until the relay kicks back in and reactivates the port. I believe I've got it set for that. And I think it has to hit 24. I'm not sure. We're at 22 now. There we go. So about 22 volts, it kicks back in. So that's not what I would call safe or happy. I'm sure that they've already fixed that in the later firmwares. Alright, so there's an interesting point about this guy. Now, let's take a look at another interesting little thing about this. Okay, so I'm going to put this up to 28 where it's happy. Be happy, be happy. Okay, we're going to plug back into here for a second. And I'm going to grab my little tiny pocket oscilloscope. And I'm going to turn her on. Boop. Alright. I wish I could screen capture off that. That'd be pretty damn cool. Okay, so if I connect this to the output power on this, I should be able to see how clean the power is on this power supply. Alright, so let's see here. So as you can see, there's a very, very minor ripple. I already pre-programmed this, by the way. Let's see here. We want sinusoidal. There we go. We don't need, but 20 hertz should be fine. There we go. Okay, so if you look here, let me just bring it up closer. You'll see that that's a pretty consistent power. That's pretty clean DC. But I would say, because I'm drawing from my bench power supply, that of course it's going to be really clean. Alright, let's take it off the bench power supply for a second. Okay, you just saw her go offline there. And now, let's plug her in to an actual AC power source. Okay, so let's see here. I'm going to plug her into the AC. Well, I've got to plug it into the AC. Might as well check the voltage output and whatnot. Okay, so she's booting. Port's not on yet. Yeah, shut up. Okay, so I didn't program that port to stay on, so let's turn it on. Yeah, it's pretty clean. I would say that this actually has some filtering, unless it's a very, very good class power supply in this thing. It's probably got some filtering in the actual output board. relay board for this thing. So, yeah, pretty clean on the DC. And you know what? Since we're now on AC, let us switch over and look at what our output power is when it's plugged into AC on all the ports. 24.1 on the dot. Okay, so that's really cool to know. Okay, so when she's plugged into AC, it's pretty consistent around 24 volts. It looks like they're just on the cusp of 24 as this varied just a tiny bit. Okay, so let's do this. Let's put this little bad boy aside. Don't need this at the moment because we're not running on DC. And let us get some probes going on in here. I want some voltage probes here. And of course I'm using this meter because it's a hell of a better one. You know, I paid 26 bucks for this thing on eBay, and it kicks the shit out of the $70 one I got at Crappy Tire. Okay, so we'll put this one aside. That one right there. I'm going to set that one for DC volts. Now let's open her up. Okay, I need a screwdriver. And I had a screwdriver. Where's my screwdriver? I usually put them up here, but I'm not seeing. That is bizarre. Where the hell did my screwdriver go? Okay, no worries. We'll just use this one. Yeah, I should probably unplug it first. Wouldn't be a bad idea. Okay, I only put one screw in at this time because I already had it apart to look at. Alright, so let's dig in. So there's a lot of screws in this. There's actually a bunch on the sides here, a bunch on the back. It's actually well assembled. Like, this thing is almost like military spec. Okay, we'll just crack her open here. And because it's got some tight leads on here, let's make this so we can actually see inside. Alright, so she's pretty basic. And of course, as you know, basic is usually a very, very good thing because it means less to go wrong, right? Alright, so it looks like, here's an interesting feature down inside of here. You guys probably can't see this. I could do a little zoom in. Where's my pointy tool? I'll use this as my pointy tool today. Now, let's zoom in a little bit. Okay, so first of all, there's a gas discharge tube there, and a diode. So there's your TVS protection right there. There's another gas discharge tube, another beefy diode. This is standard and reversed. I'm willing to bet money that you can actually switch polarity output on the ports here, so you could use it for something weird that's actually negative voltage as opposed to positive. So that's an interesting point. We'll check that in a minute too. Actually, while we're in here, we can look at everything, because there's your DC outputs over here. So, let's see. Okay, moving on. Alright, so here's your PSU. Whoa, hold on, gotta zoom out. There we go. Okay, we're back. There we go. Okay, so that's better. Alright, so here's our PSU right here. This is the logic. This is the brain right here, all of it. It's quite a small little SBPC. Pretty cool. This is just the switching. This is the DC board for the ports and whatnot. And actually, if you take a look at this, boom, we've got little relays. And they are single pole, single throw. Yes. So those are simply, well, they're single pole, double throw. SPDT. So these little guys here, it looks like all that they actually do is just cut your primary. I'll bet you that they cut the blue. That's what they're doing. They're cutting the blue. So there's nothing going on along there. Now there's actually fuses right here on the back of each one of these bad boys. So if you guys have one of these guys and it blows up on you, it looks like these little guys are actually fuses. You've got some fuses in here. That's pretty killer. So not only do you have transient voltage suppression here, but you also have, let's see here, fuses. That's wicked. And of course, here's your fine tuning for your voltage, probably for the battery output. So first experiment I want to try. Let's just see here. Let's go back over to this thing for a second. Alright. So I'm just going to plug her into DC. Because, you know, why not? Okay, now actually I am afraid. you know what? I'd be better off putting this on AC actually for the moment because, by the way, don't do this at home, folks. You might kill yourself, especially if you're in the UK or Australia where voltages are deadly. All power is deadly, but you know what I mean. Okay, so let's see here. There we go. Shut up. Okay. Are we going to short anything? No, we're not. Okay, we're good there. Let's turn that back on. I'm going to turn on port 8 again. Okay, so let's see here. So if I look at the voltage on this, I'm getting 24.1 out. Now, I'm curious as hell. It says standard and reverse. I am so sure that that is for reversing the polarity on these ports. Now, before I do that, though, let's see if that reverses the entire DC bias in this thing. So here, we've got, this is the battery. Okay, so 224-volt battery. It even says 24-volt battery on here. And the soldering job is shite on this. Okay, so let's see here. So, there's our negative. So if you look here, let's see here. Sorry. Let's see here. So there's our negative, and let's see our charging output is float. It's 27. Float voltage on a 12-volt SLA or FLA is 13.5. So that is actually just above float voltage, by the way. Going out on the charging circuit. Okay, so now let's just get dangerous here. I do not recommend this because this could end up resulting in a blown up device, but I can fix this, and we don't really use these ones anymore. There, I swapped it. Now let's see what happens. If I'm correct, that is cool. That is to reverse the polarity on this board. So that's 24 volts. Okay, let's do this again. I've got my fingers on these little leads. Okay, now watch. 24 negative, 24 positive. There's a neat little note about these digital loggers that's not in the manual. Now let's check the back again and see if that affects the battery connection. It does not. So that's strictly for the ports right there. So that's standard and reverse polarity. That is damn handy. Okay, so now let's look a little bit more in depth here. So that is going to be your voltage trim right there, of course. Let's see what else we got here. This makes a good pointer. We've got a full wave bridge rectifier sitting right there. Looks like, is it? No, that's a 5 amp fuse. Okay, so standard switching power supply, blah, blah, blah. I can't see any indicators on here saying how many amps it is in total, but I'm assuming it's probably a 10 amp if they're smart. Okay, right there, that is your voltage selector. Because actually, on the back, you'll notice a sticker that says 110 volts. So this is actually switched for, North America. But on the back of this little switch here, you can slide this over and switch it over to 220 or 240, whatever your weird voltages are overseas. So yeah, there she is, and standard switching power supply. Let's take a look in here. Yep, so there is the brain. So this would be the, if you want to call it the hard drive, that's the PROM right in there. And there's your everything. And then it's got a little Realtek chip over here, which is, I bet you it's the Ethernet chip. And then it's got a programming port right here. If you can see, it's a little fingerboard. Here's your leads going over to the LCD. And here's your button leads. And, of course, here's your relay control leads that go over to this bad boy. So yeah, that's really all there is to it. It's not much. It's a very simple Midspan PoE driver. It's not a switch, just a simple inline PoE. And by the way, I see a current sensing resistor. There's a little bridge there for current sensing, it looks like, right there and there. So it's got some slight intelligence to this thing, actually. So that's kind of interesting. It's neat how they're using a modular power supply. So I'm assuming if this thing gets popped, you can just send it back to the shop there, and they'll just pull this board, drop a new board in, and you're good to go. And that looks like an automotive connector right there, the blue crimpy, and it's going over here to the ground. Okay, so it doesn't really matter. So we've got our hot, neutral, ground, positive, negative, and then this little guy here is probably a output pot, like a trim, to control the output power of the primary PSU, and it is at 27.8. And let's see if we can adjust that. I bet you we can. This is good for different battery chemistries. Oh, look at that, 27.6. Here we go. 27.5, 27.3. Let's turn it back up. Oh look, I can go up to 28 if I wanted to and burn my batteries out. I think I want it at 27 on the dot. That'd be a smarter choice, because that's exactly 13.5 float. And that's where you want it. Okay. There are dead flies in here. Ew. Yeah. So yeah, there you go. And by the way, here's a little trick in case you guys notice this. I actually put Kapton tape over top of the piezos so that they aren't as noisy. And there's actually two piezos in here. There's one right there. There's one right there. So I put Kapton tape over them because they're extremely noisy. And this morning I was trying to be quiet and it was just screaming. So there's that part of it. Okay. So now we will go over to OBS and I will give you guys a brief rundown of the interior operating of this. And then yes, I believe that will be this video. But I do want to do a video comparing all sorts of PoE switches and PoE devices. But I need to acquire some first because I have limited access to what we actually can review and tear down, as basically it's just stuff that we've got kicking around the shop and whatnot, which is why I've started a Patreon so that I can buy equipment, or you guys can contact me and ship me equipment to repair for you, and I'll do a video on it while I'm repairing it. If I can't fix it, then whatever, bugger it, it goes in the can. If I can fix it, I will send it back to you guys with only the cost of the components to repair it, and of course do a video on it, so that might be interesting. Okay, so that is this portion of the video. I think I covered everything you need to know here except for the current output. But if you look at these leads here, I can tell you that it's probably not a lot, considering that, yeah, you know what, we can actually cheat. I'm going to pull this out for a second here, because we need to know how much current is going up to the battery bank. So let's cheat. I'm going to do this, rather than put an ammeter on it. Let's pull the fuse. Okay, what is the fuse? It is a 250 volt. How many amps? Hey, hey. 7 amp. So I would guess that the charging current output on this would be less than 7 amps. It's probably around 5 amps nominal. Yep, so that's all that she wrote for this bad boy, and I will plug in the fan controller again, and we will switch over to OBS, where I will show you the internals on this little bugger. Okay? Stand by. Alright, so now for the software portion of this. This is basically the easiest thing to do. When you want to log into your digital loggers, Midspan Poe, the first time it's 192.168.0.100. Just open it in Chrome or your favorite browser. The username is admin and the login is a highly secure 1234. That will take you into the, let's see here, never. That will take you into the PoE. And as you can see right there in big red bars, because so many people don't do this and they're very stupid for it, we recommend that you change the password. Yes, and if you really want to get secure, change it from admin to a username, because admin is the common username that most hackers use to attack devices. So as you can see here, this is your basic individual port control. So I can turn them on. You can probably hear it click. Listen. There you go. You can hear it click in the background. You can also cycle them. And that turns it off for like 5 seconds and turns it back on. It's just, it's handy if you've got, back in the day when we were using cheaper radios that would crash and whatnot, that solved that problem. You can also do auto pinging on this, which is where you can actually program it to ping specific IP addresses and reboot them if they crash. So this thing already had some programming in it, which is kind of interesting. Not sure why. This has been factory wiped. So basically what it's saying here is ping this IP address, and if I can't ping you for, let's see what it says for the settings for this. Every 60 seconds I'm going to ping you. If the 8 ping attempts fail, then it will power cycle it. Ping response to enable auto ping. Yep, okay, and then I'll wait 10 seconds before re-enabling auto ping. Times to attempt reboot twice. Device reboot delay 300 milliseconds, or in this case 300 seconds. Jesus Christ. I don't know where this thing was set up for. So anyway, so yeah, this is basically a ping watchdog that'll ping the device that's connected to the port, and if said device stops responding to pings, this switch will, or sorry, not switch, this midspan PoE driver will kill the port, power cycle, and bring it back online, and people will just be like, oh, that was weird, the internet went out for a minute. Maybe our router buggered up. Okay, so that's one thing about that. It also has a system log, which is kind of handy, but I usually use syslog servers. I strongly recommend. I believe that you can also export all of this to syslog server. Let's see here. Going down to network, here's your network settings. Administrative credentials, there's them right there. You can also add additional users and whatnot. There's your power monitor, which I don't really believe does anything. Let's see here. Here we go, syslog server. So you can have this export to like Dude or WhatsApp. I don't recommend WhatsApp, it's overpriced. Or other things like that. And yeah, alright. So here's another little interesting thing that you can do with this that I don't think anybody really uses. You can put scripting into here. That's right, you can script it to do certain things based on time or certain conditions. Basically whatever variables that it has access to in the software, it'll actually tend to. These are the serial ports. I showed you the little header on the board. It does have a serial input. It's a UART232, whatever, on the single board PC that's in there. So that's a little thing you can play with, but not recommended. It's pretty simple, as you can see. There's not a lot to do with it. That's it. Here's your setup page, so you can name your stuff. You can name your ports. South sector. Rocket, or let's bullet M2. Yeah, you see you can program them like this. You just hit submit. Boom. Now if you go to the front page here, port control, you will see that they are named South Sector and bullet M2. Oh, why is the bullet offline? Let's turn it on. Let's turn on the bullet and the sector. Yeah, they're both on. Let's just turn everything on. Bugger it. It's fun. Alright, so that's basically the breakdown of this thing. Again, it's great to use on 100 meg networks if you're running a bunch of 100 meg APs. It has 8 ports on it. Or, if you're running a 100 meg tower, you can use this to clean up your PoEs and get rid of them and, centrally manage all your devices. But, of course, many of us are going gigabit now, so this doesn't quite cut the cake anymore. This is where we're starting to look to Nutanix, which does it. But there is also an alternative to this little digital logger that is a power bar that gives you 8 controllable ports, all regular 120 volt 15 amp ports. Yeah, and that's a good solution as well. So there you go. That is everything I think I need to show you about this tough little Midspan PoE injector. All right, thanks guys, and have a great day.